think I'm up and running. Well, I know it's up and running. Just waiting for YouTube to say everything's good. Yep, there we go. Because I start my streams without audio, it always complains about the audio at the beginning. Put on some background music and I'm good to go. So, the progress from the last stream was the creation of this board, which is a 2S battery pack, lithium ion battery pack. And the holder gets soldered to the back of it. Eventually I will fix up a 3D model for it. Interesting. I just realized I did a weird cutout on the back side. And the reason it does that is because on the front side it's fitting around the fuse. But it's set to layer on both sides, so it does a weird cutout around it. Yeah, so you feed the charging power, and it is controlled by this IC here, which in turn monitors the incoming current, uses a set of MOSFETs and an inductor, because it's a buck boost controller, so it can match the voltage as needed. And then it comes to your main power bus, which the BMS monitors, and comes back into the to charge the battery. And then if you have a load attached, it also can divert power to the load while charging. The chip can monitor that, and then the BMS can also monitor charging as well as power going out to your load. Yeah, and it does cell balancing as well. Yeah. And the reason, so this trace is connecting the two sets of cells together, so that it's a parallel, or a series battery pack. The reason it goes up and around and not straight through here is because the main ground is over here and the output ground is over here, so I have a nice big ground plane connecting the two, and it's big on both sides, so the ground can come pretty much straight across over to the connector. And I'm using a lot of vias to stitch it together so that should be no issues with any current handling going to the load. And there's a sufficient connection coming across for the charging connection and so forth. And it stitches between both layers. And I did manage to make this entire board as a 2-layer board. So, yeah. And it's 42 by 90 millimeters, which is not bad at all. And so the next task is, I think I'm going to work on the circuit board for the thermal printer. It's fairly straightforward. So there's the schematic, and here's the actual board. fairly straightforward. Barrel jack, 24 volts comes in. You have a power indicator and some power filtering. Comes to a 5-volt regulator, which is absolute overkill in this instance, and you have a LED indicating you have 5 volts. And that 5 volts is purely a connection for the USB. And it should be pulling next to nothing on USB in this case. But I figured it was best to have it, so that hopefully everything functions correctly. Now there was something, oh right, I did add it. So I did go back and add the printer interrupt as an option for my programming. Figured it couldn't hurt to have it. And it has a pull-up. Realizing I put a pull-up here, but I think I have one already on the actual MCU board, to be honest. Open it up in another window. To interrupt. It's on IO15. No, it is not. Okay. So I do not have a pull-up on that. Okay. Okay, so I do need this pull-up in place then. Okay. And this is a USB hub IC, which also has its own GPIO expansion options. So I have an option that is monitoring the state of a lock, which is just a button on and off, as well as I can connect to a photo interruption IC. It's got a small IC that runs the comparator and powers up the lights in it, and picked up a few extra ones. So this was the main one I first bought to test, and then I have some other items to test later, and thought this wheeled version would be helpful for something. And then this is a smaller version I wanted to test for size and whatnot. This might still work for what I'm doing, but I worry that it does not stick out far enough like this other one does. So I'll have to play around and compare. Initially I bought just this 5-pin pogo connector, and I was thinking I was going to do 2 of them right next to each other, but I thought that was going to look kind of silly, so I went looking, bought an 8-pin that's straight across, similar to the 5-pin, but then also found these, which are dual row connections, and it's slightly bigger. I think this would work better in the 3D printing housing that I'm going to do, just in terms of size and overall mountability. This should be a little easier to work with, so we'll kind of have to see how that goes. and then so I can monitor the paper coming out of the thermal printer with one of these and control the lights, because it has a bezel on the printer that I plan to make a translucent part for, to swap for the green part it currently has, and then I can put addressable lights in it. I also broke out a few extra pins in case I decide to add things later, and then there's a third one that's internal, which is monitoring this photo interrupter, which monitors the state of a fuse. So if the fuse blows for whatever reason, the system would know that the fuse has gone out. What else? Yeah, so this connector would go to the screen and give programmability for that, and then this connector is the power connection for the screen. And the screen is set up so that it can handle the 24 volts that would be coming in. And then you have your connections for the power that goes to the printer, and power for the lock. So the printer So in the base of the printer, it's actually fairly empty. It just has this relatively small circuit board. So it just has this relatively small circuit board, which is your power coming in. This is the connection for the switch. So I'm going to end up removing the switch from there and putting a switch somewhere else. And then you have this is the power connection. The really annoying thing is they chose different colors here. So it goes red, black, yellow, and white. Red and black is actually positive. Yellow and white is your negative wires. They doubled up the pins for the current capabilities, but they chose to use a generic connector with generic colors on it instead of making a custom cable with proper coloring for a nicer color scheme. The connector next to it is the connections for RS-232, which I never actually got that working. Now that I have the proper command set for the printer, maybe I could make it work, but I'm not going to bother. I already have USB working properly and nicely, so I'm going to stick with USB, and that's this really small connector on here. So what I'm going to end up doing on my board is, instead of putting a USB cable in, just to make things nice and neat, I can just reuse this connection. So I'm going to completely swap out this board, and on the back of the housing it has the cutouts for it. Well, when I design my 3D printed housing, all I'm going to do is leave the opening for the 2.1mm jack, the power connection. So when I design my board, what I have to do is match up the holes so that I'll be able to mount my new circuit board in place for the power connection. So that will be my first task of today. Hoping to get at least 2 boards done today. I'm hoping that I can get this board done, and then I want to try and get the base station circuit board done. And then I will leave the MCU board for hopefully the last stream, and then I can start putting together the bill of materials and getting things ordered, and then on to 3D modeling. So for this, I need to annotate the schematic. And then import and see if I'm missing any footprints. Yes. Ah. That connector. That's a 2.5mm connector. So, I think that's J8. Which would be this one here. Change symbol. Connector generic 4. There. And then just come back over to here, and it doesn't comply. Cool. Oh. There we go. So basically, I had selected this footprint where it has a mounting pin because it's a surface mount connector. While the printer power connection is a 2.5mm JST, so it's rather large, and apparently I probably can get it in an SMT version, but there's not an SMT version baked right into KiCad, so I'm using the THT version, and when I go shopping I can compare and see if there is or isn't an option for it. But I'm gonna move that out of my way and start. I need this circuit board. It's got glue holding these in. Thankfully, it's a bit of a stretchy glue, so once you get underneath it, it kind of comes off in one chunk. So how's your day been, Aaron? Somebody's pinging me on Discord. I'm glad that I'm in a position where I get to pick and choose my clients, and I have good clients for the most part. let's see here. I always find it funny because my email inbox gets swamped with all the SEO and we can upgrade your website people, and it's funny because sometimes they'll try to reference something about why they're good for my business, so they've in a way taken a half glance at my website and actually read something is what they're trying to infer with it. The only problem is they didn't do enough research on my type of business. So they actually make themselves look like a fool, and it's like, are you actually paying attention? Oh my gosh, it's so bad. Plus, I've always operated on word of mouth. And a few times I've tried not doing that. Oh my god. Nope. Rather go through word of mouth. Somebody's told me, hey, so and so is going to contact you, and I was telling them about the work you do, and they were interested in something. And it's always worked many times better doing it that way than trying to rely on someone just cold calling you. Plus, if you're an SEO company emailing someone, what's actually my incentive to pick you to do the SEO on my website? Why wouldn't I just go to Google and type in SEO company and pick the person that's actually at the top of the SEO list? like, or the people that are like, oh, we can upgrade your website. Why does my website need to be upgraded? I did it myself and it's exactly how I want it to be. Yeah. Yeah, I probably should set that up, to be honest. Most of it goes to spam, but every once in a while it seems to go in the normal inbox. But what I have found is, what I have found is Gmail. I'm not using Gmail for my business, but my regular Gmail account, their spam filter has gotten worse over like the past couple years. It is bad how many things manage to get past it that are blatantly, obviously spam. Yeah, it really is likely. Actually, what I find annoying is there's that trick that people figured out where you could add stuff to your email address, and then it'd be a way of seeing who is selling your crap. The only problem is it's a known trick, and it's really easy for somebody to filter that out when they're creating a mass mailing list. So obviously it's not a very effective trick these days, which is unfortunate. Right, so with this circuit board, let's get my vernier calipers. So the width of this is that is 69.13. Let's see. Yeah, 69 millimeters wide. I'd say 0.05 millimeters is a good tolerance on a circuit board cutout. Yeah. I almost never give out my email, well, at least my professional one, and I pretty much always know when it's someone that's spamming me because they use my .info email, which is the one that I use publicly facing, so if it's coming onto that email address, it's almost guaranteed to be spam through my website. And edge cuts. Set the grid to 1 millimeters. And alright, it was 69. Probably gonna end up making it wider than this one, because yeah, that's 26.5. Let's set it to 40. Oh, just accidentally clicked. Oh, and I, so this was the one that I finished yesterday. Managed to get the project logo imported. So this one should be good to go for production. Fingers crossed I did it all correctly. Yeah, so the organization I'm doing it for, their colors are purple and like a in between a green and a forest green. It's a darkish green usually, or do they use more of a bright green? No, actually it's more of a light green. It's like forest green, but pop, more of a pop to it. I need to get a new mouse. My mouse seems to be randomly left clicking on me, or it's being extra sensitive for some reason. But yes, so I plan to get the circuit boards done in purple. I just wish I knew the RGB value for JLC's board so that this purple could better match it. If I could better match the color, that'd be nice. What are you waiting 2.5 hours for, Aaron? Now, these mounting holes. So, a few items I can add. Let's see here. I can add the logos. Oh. Yep. Fair enough. And if I'm not mistaken, I think these are M3. Yes, they are. What? Music. Can you hear my headphones? Oh. I was like, I don't need a copyright strike. I try to keep my headphones when I'm streaming at a good volume, so that A, I can hear the music, but it's not loud enough that I'm yelling at my microphone and then potentially making enough noise for other people in the house to hear me. But if you actually wanted to know what I'm listening to, it's one of my playlists on my channel. It's got some 900 songs on it, and I listen to it on repeat very often. And then every once in a while I finally go through and download a half a dozen of them. Just takes a lot of time to download them. Right, M3. Right. That pad. One and two, and they connect to ground. And we can annotate. Now these I actually have to set the footprint. Many jokes tend to go over my head. The downside to neurodivergency, at least in my case. Yeah. There's someone in our Discord group that I talk to a lot, and he gets me all the time. He's like, "That was very clearly a joke." Or the jokes that I do get is because I've already heard them before and they beat him to the punchline. He's like, how can you get that but not the other stuff? Yeah. I don't mind it. I take it as it comes and goes. I know some people feel like it's a bit of a pretty pooping move, but I'm like, my brain is logical. I'm sorry that it ruined the mood. The only part that annoys me with it is when you're on dating apps and literally every other profile's like, I'm looking for someone that's funny, and it's like, granted, I've had a few people in my life that without me trying. Apparently I'm funny, but for the most part, I'm fairly logical and straightforward. But like I said, I take things as they come. Try not to focus too much on anything negative. Been there, done that. Right. Looking for a mounting hole. I try to be. Well, I think a lot of that stems from having been through adversity. So one of my volunteer things is, because I was in foster care, I volunteer with the agency to help give back and whatnot. And then I manage one of the houses that they, well, not necessarily manage, I keep an eye on one of the houses that they use for helping people. And being able to relate and understand what people are going through, I find, tends to help in many situations. Now the mounting hole, so I try to keep that kind of mentality in mind, of that you can never fully understand what someone's going through, but you have to be able and willing to listen in the first place, and listening can go a long darn way. Top, bottom, top only. Need bottom. Why is there only top? Really? Actually, I could do it on both, to be honest. Because this board is only one-sided, and mine is very likely going to be double-sided, so I can do it on both sides. Let's do that. Hello, Johnny. There's one. Let's do this one. Oh, goodness gracious. Can I not just select the put? Oh, yeah. Turn off all the text. And then the position. Ooh. Oh, did you guys see the latest Prusa MK4 release? If only I would totally buy one. Granted, I don't do that much 3D printing yet to really warrant getting another printer. What I'd really like is an IDEX printer. The Prusa tool changer one is nice, but that thing is large, and would not fit my new cabinet at all. But been considering doing the push a bear upgrade kit, and then once I have that dialed and tuned in, I want to get the MMU and try and dial that in one day, slowly. The only reason I don't want the bamboo carbon printers is when they don't work, they really don't work. And apparently their customer support absolutely sucks on a lot of it. And a lot of it seems to stem from software issues. On top of the cloud-based crap that some of it's using. Just, no thank you. I'd rather have full local control of everything. And upgradability and stuff like that. Oh yeah. Yeah. Specs and, like, it's a great printer, it really is, but I would never justify it to myself. The fun one I get to play with this project is my new resin printer. I haven't had a chance to play with it as much as I would like to. The annoying thing is I've been meaning to email the company. I have the wash and cure system for the large version, so the Saturn. And it's great. Except the magnetic disc that spins the impeller inside the wash chamber. So the magnetic disc that sits on the motor, the set screw on it broke. And it broke the plastic magnetic wheel with it. So it doesn't work. See, I don't mind the sound of a 3D printer. One, I'm partially deaf. Two, I love white noise. So if my printer isn't running right, I immediately know it's not running right. In my closet, you can barely hear it. Most people in the house don't realize it's running. But once it's in my new cabinet that's got some decent soundproofing in it, it's going to be very quiet. But the cabinet is set up nicely, good lights. I've painted it, so it's going to be really fun to set up a webcam in there and be able to do streaming of my 3D printing. Yeah. What's really annoying is my normal supplier for filament. They used to have like this economical lineup of filaments. They still have it, but only for their PLA line. They don't seem to have it anymore for their ABS lineup. And I haven't emailed them to check if their standard ones are the same color format, because once they were out of stock and I really needed filament, so I bought a different black filament from another supplier, and it printed like a black green color. It looked so bad. And then that's on top of the fact that every other company seems to be having stocking issues with their filaments. And I'm not using PLA for this project. I want ABS because it's what I'm really good at printing. Like, I'm really good at printing ABS. And then the overall durability, and my plan is, even with the printing of it, I do plan to do my normal thing, which is sand the housing. I'm not going to do a full like 2000 grit polish, but I'll probably go to about 400 wet sand, just to give it a nice smooth finish. And then I have an ace up my sleeve that I found. I've done it with both a plastic polish, mostly just rub it on, let it dry, and then you can rub it off. But the other thing that I found works really well is petroleum jelly. It gives a little bit of life to the plastic, but it doesn't make it look as dull, which is good, especially after you do wet sanding on ABS. It tends to look really terrible until you polish it. But that's my plan, and most PLAs do not sand very well, and I might have to do a few parts where I have to glue things together, and it's a lot easier to acetone weld ABS parts, I find. But that's my own preference. But I needed a calculator. So 15.5 plus 20. 25.5 and comes across 19 plus 20 should be 39. It's probably loud because of the speed it's running at. Printer is fast. And 35.5. How far down is it? Yeah, Johnny had actually joined the last live stream, but right as I was finishing. Hoping this stream I will finish this board and the base station if I can get lucky, and then after John's stream tomorrow I can do the MCU board. No, I did not make a smoothie today. I actually need to go grocery shopping, but I think I have enough to make a smoothie tomorrow, although I'll probably drink it during John's stream. Pardon me. Lock that into place. And then the only other critical part is the power jack, which sits, pretty much sits right at the edge of that board. It's 1 millimeter off. I know it's probably going to be more. I'd be tempted to print this out as a 1-to-1 on paper. The other thing I can test is set zoom to 1-to-1. Yeah, that matches. Yeah, cool. Thank goodness for zoom. Be tempted to move this forward slightly because I am gonna build a housing. on the printer. Yeah, so it'll make it a little nicer for plugging it in. Yes, there is. It's in my hand. But I'm not using their RS-232 or their USB jack, so I'm going to bypass it. So my board is going to have... I'm going to essentially be removing this from their printer, adding my board to their standoffs, reuse the opening for the 2.5mm, but when I build my housing, I'll end up covering over the other spots so that you can only input the barrel jack. And then the other thing I've done is, so the USB host IC has its own GPIO expansion options. So one of those options I've used to control some MOSFETs, so I can actually turn the printer power on and off, as well as controlling the lock and sending commands to the printer as needed. So we have the lock. Oh, it's paper. Sensor. It's this one. This one is power for the LCD. Put that one over there. That's your printer connection, which I'm going to put next to that one. USB, and this is the printer power. Should be able to get away with it being this way. So I'd be tempted to move this over here. The reason being is because this always has power, whereas I'm doing power switching for this. And then well, actually, no, I can do that. Let me move the schematic to my upper screen. And MOSFETs. There's 1 and 2. power comes in. I can bring it over to here. Want that like that, I think. That way power can come around to there. Which one of these is the control? That's annoying. This control needs to come across. Which means I need power. Oh. Switch to a copper layer. And power. Only needs to be on the one layer. It is priority. Change the grid. What's this one? Oh, it's for the lock. Let's put it like that. I think that makes sense. Well, I'm obviously at mine, but I don't need a squirrel to chase at the moment. Oh, I just realized. I am indeed gonna want lock power over here, because otherwise I gotta carry the power all the way over. So. Actually, I'm gonna want USB over here too. Maybe could fit them, but I don't necessarily need them to. There's enough width in the case that I can do side mounting if I need to. I'm mostly trying to figure out the best way to run the power traces. Let's see. I'm not sure all of them would actually fit lengthwise, to be honest. Let's see. No, they wouldn't. You'd still be missing this one over here. I think that's all the connectors. Yeah. Oh, I used the wrong footprint on that. Let's see. Aha, I knew I had a footprint for it. Yeah. Now I can extend the width of this board, but I can't do the length here. But let's do this. This over here. Set up my track sizes. And then lock. And let's see. No. I want to alternate. That is because, where is it? Got a fuse. Man, that thing's looks so small in the photos. Granted, it is small. Everything on this board is relatively small, so this ends up looking big. So we can do that there, and then this. Let's do it like that. From there to there, and then this comes over to here. Put it like that. I feel like, yeah, there's a resistor there. Yeah, my mouse is acting up today. Oh my goodness. The other one is this one here. And then this LED here. That is the main power LED. And it has a resistor. And there's this LED, which is the 5-volt regulator LED, and it has this resistor. I'm clicking it in the schematic, which jumps it to the right spot in the mess of parts in the PCB view. Saves me going hunting for everything. and I'm looking for something specific. This LED is status for the lock. So this LED lights up when the lock is told to be on, and if the fuse blows, this light doesn't work, but also it doesn't actuate the opto-isolator, which in turn tells one of the GPIO pins on the IC its state, and thus I can learn if the fuse has blown. And what I'll end up doing on the 3D print is I'll leave a rather small inconspicuous hole somewhere so that you could fish like a wire through and manually actuate the lock, because all the screws and everything will be designed into the housing. So if you absolutely need to bypass it, you can unlock it and get at the electronics. So power comes in, comes across, comes to here. And I'm realizing I might actually want to shift this over because I need to fit in the 5-volt regulator. Fuse. So let's come over to here. 5-volt regulator. So you have the regulator, got a capacitor, output capacitor, got the inductor. Why does it do this? I don't understand why it's done that. Every design I've tried importing that inductor, it doesn't want to work. So do it again. Copy over the part number. And it is the SRN 4018 footprint. Past it. There we go. Imports. Copy that, transfer it over, delete the original, bring it up to date, let's change it to L1, bring it up to date, there we go. Not a convoluted process at all. capacitor. Capacitor number 2. That is everything for the 5-volt regulator, and then this LED is the power light for it. So power comes in. Power comes in. This connects to that. Yes, it is. It's a fixed 5-volt regulator. It's really nice. It's good for 2 amps and small footprint, minimal components. You can get it in 3.3 and 5 volts, and then an adjustable. Volts. And the inductor. This goes to there. So this comes over to here. And this is purely for the printer's USB 5 volt. Not that I actually think the printer is using it, but I think it helps. There's an interrupt that I haven't seen work when I'm testing with the ESP, but it works on the Arduino Uno. So I'm hoping that having the 5 volts properly wired will allow that interrupt to work properly. If not, then it doesn't really hurt anything by having it. And because I have all the code working on the printer, it's not hard for me to ask the printer information, and if you don't get a response, then you know there's a problem with the communication. Nope. Smaller. Oh. And 5 volts can come through there. Voltage. And now. I still need power for that. fun part is always figuring out the initial layout. So, power. And come in. And then the lock connection can come here, and power can come down this way. So this connects. I think it's okay like this, because so this is the 5-volt pin here, so my plan is just to use a copper fill right around the pins, so it all lines up nicely, and then copper fill for the power right in this corner, and then you fill the power for the printer, so it all kind of flows nicely the way it is. And I'm not too worried about the size of this. I can still increase it if I need to. That one comes to the LED. then this one is the main power LED. Let's see if I can make this work. Higher priority, and then need to adjust the tolerances. 8, and smoke 30. Silly me. There's 2 pins. Connects that. Put out power. What? I think I might have to finally bite the bullet and buy the mouse that's been sitting on my Amazon wish list for a while. I'll show you. I forget what the name of it is. Well, I think I know what it is, but I'm gonna double check what it is. I have way too many items in my wish list. It is the Logitech MX Master 3S. It usually goes on sale, but right now it's $140. Now, granted, this cheap mouse, I've had it for a couple of years, so it's worked well, all things considered. But it's I've noticed the scroll wheel is acting weird, and right now it's doing double clicking, which is annoying the heck out of me. Yeah, it was the Logitech was recommended to me by someone else. The keyboard I'm using is a Logitech. It's a very basic keyboard. Oh, I flippin' love it. I'm gonna buy a second one because the face of this one is kind of deteriorating. But it's a $25 keyboard, and it's like I'm just so used to it. It's perfect height. I like the decent clickiness of these keys, but I've tried using larger, older style keyboards, or the keyboards with the cherry keys that everyone's obsessed with. Nope, can't do it. Cannot do it. I love this keyboard. Power. I got a label. And then my webcams are all Logitech 920s. They work really well. I like them. Who knows, maybe one day I'll be a proper YouTuber and I'll have HDMI capture cards. yeah, I've been happy with them. Uh, yeah, I should really work on that. The lanterns are on. They're just too high up on the wall. I'd love to get the flame effect on the bulbs working. That'd be nice. Actually, a good option would be to. I've been thinking of putting like. So the way my monitors are mounted is using cast iron pipe, so that I could do my 4 monitor setup nicely with dual bars that I already had for dual monitors, and then I just bought a spare bar, which was really cheap for my original mount, and then all I had to do is take some cast iron pipe and make an extended piece, and that's how I mounted the 4 monitors nicely. But I've been thinking of doing that across from the wall I built to the overhead bin storage, and then use it almost as like a curtain rod and put a green screen up. Then you get another webcam, or you take video footage of the lantern and use that as a backdrop. Could even go a step further and do what Sion has for his logo, where it's controllable through chat. And so the lanterns actually have a flame. I hacked a flame effect bulb and took out the circuit board from it. So they have the flame effect bulb in it, and I went with red because I thought it looked nice, and it does look nice. But I haven't finished wiring up my rack, so I can't activate them yet. But even on static colors, it looks really nice. Yeah. The other thing I have on my wall is I have a 3D printed plug, like a blanking plate, on a spot on my wall. It's centered to the wall. And what I had planned to do, so Big Clive has been doing a few tutorials where he would 3D print a U-shaped channel bracket that you would fit that neon LED rope into. Well, I've been wanting to do the same thing, but do it as my logo, and then use NeoPixels inside the LED rope, and do a decent sized version of my logo on the wall that can light up. But that LED rope is kind of expensive, and I just haven't done it yet. My list of I want to do this is really long. Pretty much. I think it'd be kind of unique. Especially because my logo is a light bulb with a gear in it, so you could, especially if you're using NeoPixels, you could do some fun animations with it. Actually, I have a desk stand. I'll have to find it for my next stream. I think I know where it is, but it's a small version of my logo. Actually, I think I know where it is. Hold on. Found it. Okay. Here it is. So I built this. Let me plug in a USB supply. I built this. This was like one of my first few projects I had done with my 3D printer, and I've done a few of these with people's names, and then customizing it. So like one person really liked flowers, so I did those with flowers in it, and then another person liked dogs, so I did those with paw prints. Let's see if I can find a photo. Google Drive. Here's one. So, I did this one. So it's a 3D printed case similar to the one here, but I did it in the person's name, and they liked dogs, so I used paw prints in it, and it's got NeoPixels inside of it. Let's see if I can find the other one. And it looks great in person too, which is always the bonus. The other thing I've done with 3D printing is I've done stuff like this. So it's white and it's 3D printed, and then I did my trick of using nail polish on things and went over the top of it so it's embossed, and then painted red over top, and then the rose is printed in orange, and then I just highlighted the tips of everything with the red paint. Simple stuff like that is always fun to do. What else? Should have. I think it's in my archived projects. I had a photo of that one, but I didn't save the photo of this one. Yeah. Well, nonetheless, so this is the one I built for myself. Let me switch the webcam. So on the side, the power button, and then so the default mode is it just does that. One of these does brightness, I think. Oh no, I initially had multiple modes programmed into it, but right now it looks like I only have the one program installed. But yeah, so I would every once in a while I've been at like a convention or something, which I have one of those banners that I use for having a booth somewhere. The stand-up banners that you pull out of the thingamajig. And so I would put this on like a table, and it I found it was a good way to catch people's attention and have as a conversational starter. So yeah. Yeah, it's really swamping out the camera. Yeah, of course. Just this was my early electronic stuff, so I should have used LED strip in all honesty. So I soldered up these 10mm individual ones. This was when I first really started building stuff, so it's a mess in there. So it's just the LEDs. There's an Arduino Nano in here. And I think the way I set it up is that they're actually two individual strips, so I think I can control them separately. But I'm not 100% on that. And then the buttons also have LEDs built into them, so I can control them too, along with seeing the button presses. And then it's just got a screw in the base to let it stand upright. And then just a piece of white printed as the diffuser, and then I just glue it together. It does want getting an upgrade at some point. Yeah. Well, the best option would be just use an ESP8266 and what do you call it? LED strip be your best bet. And the reason for LED strip is because for like the other displays that I did the same thing. I was trying to solder those 10mm PCB versions, which is really annoying to have to sit and solder because you're soldering really small links of wire. So ideally, if you use the LED strip, it means you can use the same control circuit board for different size displays and whatnot. Right, so for this, what I'm doing is going into the schematic and labeling some of these nets so that it will let me copper fills for them. Yeah, no worries. And then update it. What that lets me do. See, it's labeled now, and come in here. Why is it not filling that in? Oh, I selected the wrong net. I need the printer fit. Weird. Oh well. So that connects up to there. In all honesty, I could probably come right up to there. That connects across to that. I can come all the way down on this. Let's go across there. Don't need to come all the way down. Fix that there. There we go. So that connects that together. Let's do the 5 volts. The reason I wanted to move this over is because I'm going to come right through with the polygon. Try and do this nicely. Now, ideally, thinking, just move this over so that this can actually be a straight line. No, not what I wanted to do. I'm going to remove the corner. There. Like so. And that connects that across. And so power comes in, connects to there, comes to here. Got USB lock connection, so the lock come here, and we can label. That connects that like so. And so what we can do here is don't really need to worry about double siding these because they're not moving much current. So we can do it like that. And what I can do is move this to here. I'm just going to run traces for that. The LED I can mount like that so that I can share ground. Connect the LED to that, connect that to there. And then all I need is connection between the two MOSFETs. And basically gonna do what I did here. 1, 2, 3, 4, 5. So, polygon, looking for a lock FET. Connects that to there. Connects that. should be the same for both. Yep. So that connects those together, and then need a fill to come around from here to here for the lock. Set the grid. And that is lock power. I'm gonna fix these out so that the angles are a little nicer. So power comes off of there. Let's see. What's the best way to do this? Let's fix the grid. That connects to there. I'm trying to decide if better off moving that. These are really wide open space, but I can do ground fill there. Actually, that kind of works in my favor because ground fill can come all the way around and connect to ground over here. And I think there's enough space here for ground to come over to there. Let's see. Actually, if I move this over, I can make, no I can't because it has to connect to the actual port, and I'm not going to be pulling that much power anyways. This should be more than capable of handling everything. Right. That is fine for that. Let's fix this. Move corner. Okay, there's power for the lock. I'm just realizing I placed these really far away. Oh, Aaron. Now, granted, it would probably have bothered me too. Ended up waking up myself. But I want to get these designs done, so. It's a really big trace. Let's go to 20. We'll use 26 on these ones. Probably move this over slightly and give myself a better connection to the fuse, but that should still handle the current more than enough. Let's see what I can do. Let's move these into position. And then that leaves the IC. I see some work to do. What's this resistor for? Oh, I added a LED to the one of the output pins, so that for debugging, if I wanted to make sure things were running properly, I could add like a blink command to the code. where it essentially just cycles the light on and off continuously as a way of making sure things are working properly. That resistor goes with that. That goes to pin 2, which is over here. Trying to decide what's the best way to do this. So ground connects to there, connects up to there. Well, we'll connect up to there. 3.3 volts. 2 I/O pins are there. And then you have 2 extra output pins. And the crystal connects to pins 25 and 24 in this corner. Pin 3 goes to pin 25, that's to 24. How did you get there? Capacitors. This is for this pin. And this one is for that pin. Put it there. That connects to there, that connects to there. I'll probably put a V in here. And then that leaves this to go here. As a pull up, and then that connects to those pins. And there's another one extra pin. That needs a pull up. And then This are the pull downs for the outputs. That has an LED, and then on the set of these pins comes to the output. Man, that's a big. This close because it's a capacitor. This resistor is for the interrupt pin. Which is over here. This capacitor comes over to pin 22. So there'll be a via in here. And then you have your USB connections. And this is the capacitor for pin 23. Yes, this is the printer board. So, built into the printer is this circuit board, which has a 2.1mm jack, RS-232, and USB. So instead of using this, this board will replace it, and I will use the direct JST connections for what I need. One of these is for the power switch, which I'm not using. So I'll be removing it, and I have a power switch that I'm going to put on the screen. The screen has, on this circuit board, has the ability to control a set of MOSFETs to power up the printer instead of using a power switch. And then I'm not using the RS-232, but I will be using USB, but I'm just going to bypass using a USB connector and simply use the JST connector they're using. So I'll be able to shrink the wiring harness a little bit because I don't need all of the wires. And so I've done my power tracing already, and I'm just getting the traces for oh, what do you call it? The actual IC in place. Hoping to get 2 boards done tonight. I want to get this one, and I want to get the base station one done. Why do I feel like this symbol's backwards? It is. This should be pin 2. This should be pin 1. The symbol on the schematic is right, but this was wrong. And this is to act as a flyback diode. In all honesty, this is an absolute overkill of a diode. Let me switch that. The other one that I like using is the SM4007, and I already have it on my parts list, and I don't think I'm using the S3MB for anything, to be honest. So let's condense my size-wise, no. This is smaller. So I'm matching the width of this, and I've matched the mounting points, but I've made it a little longer. It's close to the battery board. The battery board is like 90 millimeters wide. Let's see here. This is... oh. I'll have to switch the measurements in a moment. .40 by 69 millimeters. The battery board is 90 by 42, I think. Yeah, no worries. Now, normally I don't use mounting holes with copper on them, just my preference, but this board did tie its mount to ground through the case, so I figure it can't hurt to have it electrically connected if that's what they were doing. Might have to put these off to the side and use vias. So what I can do, do that, run the trace through to there, the crystal. I can rotate. Like that. It's gonna get tight for the traces. So let's move it over here. And then these sets of pins. Let's just put them here, I think. Do I want to put them over here? Might just be easiest to put them over here. So 3.3 volts comes up through there. We get a connection through there. Okay, so let's do a test. So this comes up through to here, to there. I think I got my pins backwards. Oh, I gotta fix the footprint on that. I'm not using that large of a diode. It's the right one. Okay, save. We update that. Move that down to here. There. Let's see if this works now. Oh. Yeah. So that's that connection. This connection is a little close to the edge. To there, to there, to that. Actually, save myself a little space. Do it like this. And then 3.3 volts comes through here, cut across to that. Five volts, and then you have USB, printer interrupt. Ideally, I'd like ground to be able to fit there, so let's move this stuff back. Oh crap. I think I just saw lightning on my security cameras. My power is usually stable, but I'll give the heads up that there's always the possibility I lose power. I do not have an up system. I really do need one. Actually, I need more than one. Let's see. You got the system in the garage, you got the cabinet downstairs, and you got my bedroom, so I need at least 3 of them. Actually, what I need to work on is my reboot procedure. Takes about 20 minutes for me to get everything back up and running. And nothing's automatic at the moment. The Linux server running Node-RED and whatnot, I think I can set BIOS to auto reboot on power restoration. I just haven't done it yet. The other problem, well, I think if that boots fast enough, the devices won't care about MQTT, but almost every device has a problem with not re-grabbing MQTT or Ethernet properly if the systems aren't up to running fast enough. I know my DCHP server does not come up fast enough, so pretty much every device has to be cycled so that it gets an IP address and then also thus connects to MQTT. Although it's possible that they did get their, I don't have screens on them, so it's possible they actually did get their IP addresses. They're just not connected to MQTT, and MQTT times out so quickly, especially if it takes me an hour to realize the power was out because I'm asleep. Then yeah, having to reboot everything to get them to connect. Which isn't bad, but I'd like to have a bit of a procedure to do it. See, everything I'm running is all local control custom firmware, so I wouldn't have that issue, thankfully. Wait, what? How did that happen? Pin 1. Yeah. What? Pin 4. Yeah, I wouldn't really need large ones, but I want decent ones. For me, it's just, it's not that I'm not knowledgeable enough to do it, it's a cost issue. It's always cost is what holds me back. Downsides to living on disability. I'm gonna have to add in vias for all of this, but let's see here. Tempted to do that. Oh. Don't need that anymore. And here's that one. 3.3 volts comes from here, and then you have so that's 3.3 volts. And then we have 5 volts, which can come over to here. USB connections. That's USB. Oh, right. I'm gonna increase the track size on that in a moment. I'm just trying to get everything to fit first. So I need control for that. And what else? Oh, control for that as well. Let's see here. That goes over there. Frontal control is over there, and then have this one. This one. No, I want it to come this way. Why is it doing that? That is weird. Come on. What? Oh! There's a Vias in my way. No wonder that was happening. So ground should be able to come through there. And then see if I can fit these over here. It's pushing it. If I move this. This way. Should be able to fit that now. There we go. And hopefully I can fit that here. Not really expecting to need to use these, but I figured I'd put them there just to be safe. And then these. Are needed for that. Not really the ideal way to run that trace. Especially because I won't be able to upsize it. So it's probably going to have to come around, and I'm going to have to go up and down to get it to work nicely. Yeah, that's actually maxing out the size on that, so let's do that. I want to try and see if I can't go in between these pins and make this work. Or at least minimize the number of vias that I have to use. Just gonna try and see. Chip select. I might actually pull this off. Come up through here and around, around. Around. Not gonna be able to fit through there. Bug. And then we can move it down. Might just be enough space. I don't think it will be. No. Oh, it's so close. And I'm making space here so that I can do this 3.3 volt line. Might just pull this off. And then USB lock is connected, that's connected. So the only other one to worry about is these two. What I'm gonna do is go across to here. So cross, up, nope. Let's try that again. Come across, come up and around, yeah. Then we come across, on top, and across again. And this one does the same thing. Okay, so put that back in place, and what I can do is fix it from this side. And 3.3 volts is probably going to come up this way. Well, let's see here. And then trying to make sure that when I do my ground fill, ground has a way around everything. Although I'll end up shifting stuff, I'm sure, once I put the ground in anyways. That goes there. Where does that connect? There. Let's make those smaller. This can go like that. If I move that up, I can move that to there. And then should give me enough space. This one. Connect there to there. Actually, let's do it like that. Tee off of there. The reason I'm routing it that way is because the top layer can also connect to this ground lug and then pass it to the bottom, so it gives a good current path no matter which way I run it, although it's slightly ideal to just have it connected. So let's see here. Like so. Move that like that, and I should be able to get ground through there. And then let's move that like that. Fix that in place. Might have to move this fuse up a little bit, down, sorry, so that I can get ground all the way around this lug. But I'll see when I go to render it how it fits. Fantastic. That fits nicely. There. So the only thing that should be left is these pins and the 3.3 volts and ground. its way through there. I'm hoping. These pins. And then so the fun task is I need 3.3 volts. I can get it over here. So that could work. Okay, so if I have 3.3 volts over here. I should be able to get ground through there. Well, I'll see in a minute when I go to render it. One thing I want to fix is this connector. I always try to give 1mm gap around my circuit board for ground fill and whatnot. Just my own tolerance that I normally do. overkill, but a tolerance that I like to use nonetheless. Go back to a 1mm grid. Oh, set it to copper layer and ground. And the other thing I have to do is I'm going to increase that. I'm going to decrease the priority. Everything else should be able to stay the same. And voila. Oh, I know why it's not showing up on both layers. And it select both layers. There we go. There, now I can connect across. That's connected. I wish that was connected there. It's not going to. I'm not going to get it to go on that. There, that's better. That way it's not isolated and it connects all the way around. It'd still be nice if that was connected. But I don't think that's going to be possible. There's nowhere to go. That is connected. Let's put a bigger trace in there. Not that it needs it. It's connected. Connected. Works its way around there. Right about that. That's fine. But I do need to connect that. can do that. That's better. And then, oh no, ground makes its way around that. That's fantastic. Awesome. I can put a, let's move that like that. I can do that. There. Put a via for ground there. Let's move this and board. Actually. There, I can get ground all the way around on that. That could connect like so. Well, that might be a tolerance issue there. See if it throws an error. Power, ground, that connects. I knew that was gonna do that, so I'm not too worried. I'll do a bunch of stitching vias. Same for that. Same for that. But let's run the DOC before I do all my stitching vias. Oh, I forgot to turn these off. And oh, it's gonna complain about that part. Exclude and exclude. And the unconnected item. And toward that. It gives that a ground connection. Ta-da! That passes a DOC. So let's see where I can fit the logos. Let's see. Date. Oh! Happy Fool's Day, folks. I wonder if I can edit that in the library so that I don't always have to turn those off. Let's see here. Haha. I can indeed hide them. Alt 3. Where is going to be the best spot to fit these? So that spot here and there, I think. Text can fit there, I think. And can I, all I need is the text. Oh, that's annoying. That works. And then that over. Text. This text? Or this text? Oh, oh, you mean put this up top here? Yeah, probably could, but I wanted it near my logo. Save that, and we'll go into here. Right. Yeah, probably could have. let's see how that turns out. Oh, fantastic. Oh, I love it. The fuse doesn't have a 3D model. Interesting. Everything else is there. Awesome. Now the only... I'm not actually going to put the pin headers in this, I'm just going to leave them with their bare sockets. I wonder if I could turn that off. I feel like that's an option. Exclude from bomb. Exclude from position. I think what I can do is I can edit it like this. There. That's what I want. It's not 12 volts, it's 24 actually. The printer runs on 24 volts, 2 amps. But yes, I probably should put a label on it. I'm actually going to put a label on the bottom side for these pin headers once I finish editing them. The extra inputs and outputs. Figured because I'm using these resistor networks arrays, figured I'd use an extra 2 pins. So if I decide to try and add more functions and I want to prototype it, I can do so before having to fully spin up a new circuit board. But I don't fully expect to really need them because I've already added the sensors that I want. But if I want to prototype something, they're there. I think there's still an extra like 3 or 4 pins that I could use. So there's even more options for added stuff if I need it down the line. But that's also why this is V001. Let's add that. That connects that. Right, I wanted... Oh, making it really large text. I'm just gonna label it like that. And then two. Actually, into three. What I'm missing here is another ground connection. Now for all the stitching vias. Now, really don't want that ground sitting there like that. That should work. Oh yeah, Chris has been working on that for a while. Ooh, and the lightning starts. Lots of lightning now. Yeah, I know that feeling. I have so much software to develop for this project. Ooh, I'm gonna be busy. No. That is true. The one that I'll probably get working the fastest is going to be the printer. Because it essentially, the printer, the screen acts as an access point, and generates its own website. That website I already have done. And from that website, it the only other thing to add would be the back end. So it once you input information on that website, the ESP takes that data and generates a receipt. Actually, I have one printed off. It essentially generates a receipt with the information from the website, and then encodes a QR code, which is what you scan when you're gonna log that person's donation. So that website and the capability of printing is done. What has to be added is the RFID unit will be added to this as well once I get more of them. So you'll have the ability to log in and see previous data if you need to reprint something. So obviously I need to be able to send that data to the server for safekeeping. And then the ability to recall that information for printing. I'm going to be building a so I want to try and make as many things customizable. So I've started making notes for myself in a document of various functions that I'll need to do. One of those functions is the login. So both the printer and the scanner will share that same library where you can either use the RFID, I'll have a keypad option, and then no login whatsoever. And then so that'll be one of the main things, is working on that login system. And yeah, so that receipt isn't a receipt we give to the donor, it's a receipt we use ourselves internally. So when a donation gets dropped off, what we used to do is there was a code that you could fill out, and that code had all your information on it, and then we would staple it with your donation, so that when we have like a bunch of donations sitting to be inputted in the computer, you know whose stuff belongs to who, because sometimes you have to issue a tax receipt or whatnot, but also just for general, because it's a government-based organization, you have to keep track of everything for auditing purposes. So the receipt that comes out of this printer is for internal purposes. Just instead of having to sit there and retype that person's information, or in the case of the handwritten ones, reading people's handwriting can get kind of difficult. So being able to have this thing just generate a QR code, the writing is there just as an added backup, but the QR code is what you really want, and that can be scanned by the barcode scanner. And I've already set up a custom library for that barcode scanner so that it posts all that information. I have it set up to do it in JSON format. Initially I was going to use the so QR code has some standards to it. The one standard is a V code format. The one before that was me code, but V code's the newest and greatest. But it was taking so many lines of code because it's essentially a string, and you'd have to chop it up to find the data you wanted. It was taking too many lines of code in memory, so I said there's really no reason for me to stick to a standard that really requires more effort on my end to program, when I can just make it JSON based, and I already have 2 other sets of QR codes that are going to be JSON based, so I'm already going to need the JSON code as well as just make everything run on JSON, which is what I've now done. And yeah, so I already have that set up to work. Yeah. Yeah, I think that pretty much covers what I wanted to say. But yeah, doing all that programming, it's going to be a fair amount of work. It's the modularity that I want to try and accomplish that's going to make it very difficult. Well, at least to start. But I'll thank myself when someone else wants to use the equipment and I have to set it up for them. Not have to reprogram it all. Oh, that thunder is rumbly. I felt that. Yeah. Let's see. What the document here? What else did I start writing? The other part for the scanner is the user roles. I'll have to set that up. And then it has essentially 4 modes. You can sign inventory out, which is essentially default user capability. Certain people would be able to sign items in. Then you have the printer operation. So from a scanner, you'll be able to print the asset tags, which essentially would be the way I'm setting up the categories is there's a main category So I have a example of that. Example, where is it? So an example might be self-care, and then you'd have a subcategory, so let's say soap, and then typically we get 2 types of soap. Then you would have so you have your main category, subcategory, and then the item. So for soap, we typically end up with 2 types that get donated. Either it's a kit where it has like body wash. Oh no, it's fine. I don't care. Has the it's a kit with multiple items in it, and then the other is just individual like body wash. So then you'd select which one it is, and then it would print off a tag. Now I'm actually going to have more than one printer, but the system would be able to see the printers on the network, and you can select which one you want to print to. So I'll be setting that up, and then what else? And then it has a settings menu, and then the settings menu has various items that you could pick and choose what's actually active for a user, like network information. An average user doesn't need to know that. You don't need to be giving them the MAC address and ID address and all that kind of stuff. So you could have that turned off. And that's what I've done so far. And then you have user roles. So I'm going to set up, I think, 4 different users. Your regular user, which essentially just lets you sign out items. You have the advanced user, which lets you sign in stuff and access the printers. And that would be essentially anyone that's set up to log in new inventory. Then you have your expert user, which essentially would be your IT personnel. And then top tier would be the programmer, so me. Don't give that role to anyone unless you know what you're doing. Touch the wrong setting and you're going to be swearing at yourself. Yeah. And then login options, you have no login, keypad, QR code. Because the circuit board that will be attached to the printer is the same circuit board inside the scanner, you could easily add a scanner to that, and yeah, I'm making backups of all the code and everything, and then RFID options for login. And I'm going to set it up so that login, you can customize which login options available, but I'm also going to set it up so that you could have 2 running, and for the most part I think I'll limit it to, like, if you're doing RFID, then you could also use keypad, or you could use QR code plus keypad, but I don't think I'm going to make it so that you could use like all 4 options at once. I think that's just going to be too much overhead for me to constantly program around. Want options, but I don't need that many options. So, yeah, it'll be fun to work on, that's for sure. And then back-end wise, you have to keep track of everything. You need to generate the CSV files. Also want a website that can show you what's currently available. And then once the ATM machine is built, that needs its own website. And that will be a much bigger website. Let's see how this turned out. Oh, I used vertical ones. Why did I do that? I thought I was using horizontal. Yeah, I'm hoping. Let's see. I should rotate that and fix the font for that. No, it's... So the board sits in like this. Flat. So, I have a little bit of height, but, well, you don't want to go above the height of the 2.1mm jack. That seems to be where the limit's going to be. Looking at the sheet metal housing on the bench. Yeah. So let's pull this in. Fix this. So that should be... horizontal. Was the USB 1 point? Yeah, I think it was. Let's see. Yeah, it is 1.25. Okay. What? Why is it not letting me drag anything? Oh, the pin numbering is different. Oh. Oh, fun. this. Oh, like that. Huh. I had the right footprint for USB selected. That's nice. Let's see how that turned out. Oh, what? Oh. Lock and ground is swapped. Oh. And it does it for power too. Darn. That's fine. Let's see. Got a bigger ground connection coming through here. And ground can come through there. There. Let's move this up to here. So that, because the lock is going to have some of the biggest spikes, so you get nice ground coming right through over to the second one and back. I would almost want to run this trace up and around, but even the connection between here and there is fine. So the only thing left to fix is my blunder with phono connections. Awesome. Let's do the design check. 3 warnings. What's wrong with it? Co-located. Except at place 2. Ta-da! Cool. So, let's see how we're looking. Much better. Wait, that's still vertical. Why? What? Gosh darn it. Which now makes it fun because I have to get 5 volts over to the wrong side. And the USB traces are backwards. Absolute overkill for current carrying for these pins, but shouldn't really be pulling much power on 5 volts. But I'm hoping it allows everything to function properly, which is why I'm adding it. I know the IC will run without 5 volts on it, and I know the printer will respond, but there's an interrupt function in the printer library, and I wasn't noticing it trigger when using an ESP, but it did when using the Arduino Uno. And I'm hoping the reason for that is the difference of the 5 volts being connected or not. There we go. Let's check. Like the fact that I've gotten this board to be 2 layers as well. The LEDs connect to the screen circuit board. That's a function built into the scanner board, and that board gets shared with this board. So the only thing that needs to connect between this and that other circuit board is the power and the SPI connection. That's the bonus of how I'm designing this, is I save myself the number of boards I have to make, but if for whatever reason the board that's on the printer stops working, I could temporarily take one of the 4 scanners apart and move it over and just put the new firmware on it and have it work, and then go back and assemble a new circuit board and find where the issue is and do a revision if necessary. If a board fails, I don't typically put it back into service. Typically figure out why it failed. But it's been a while since I've had a failure on a board. On a board that I've actually put into service, I mean. I've had failures on the workbench, but not on a board I've decided to hand out. But hey, that one only took 5 hours instead of the 8 hours, 7 or 8 hours yesterday for the one board I did. But, yeah, nice. It's a little more complicated. Well, maybe not. I don't know. Let's find out. I'm gonna do it anyways because I'm hoping that the end of this would be. I got 2 done tonight. So the next one is the base station. Which is Ethernet based. Now, so this is the base station. It's mostly straightforward. Yeah. And now this one doesn't have any constraints on the size of the board. Well, actually I was thinking of streaming after John. I was gonna watch John's stream and then stream after John and do the last board, which is the MCU board. Now for this one, wonder if I can copy it from the project it's from to save me some hassle. Let's annotate this. Let's completely out. So the MCU board is what actually runs the scanner. So this is the screen that I'm using, which is the WT32 Plus. So it has this board attached. I'm removing that, and the board I'm going to design has the connection for the screen right on it. So my board will interface where this currently does, but it adds all the connections for everything else. So it has the connections for the RFID units, the you can input power, so either the battery or in the case of the printer it gets power from the plug. For the scanner it gets power from the battery board. That's how that's going to work. So the MCU is the main thing that runs the entire scanner. Want to see if I get lucky and it tries to link these. No. Just gonna try and redo it. Yeah. Yes. Yeah, the one I did the other day is just the battery pack on its own. Nope. It doesn't like doing that. That's annoying. Let's see. Oh. 124. Oh, that's been 48. So I'm putting the barrel jack and a terminal block because the barrel jack will make it easier for me to test temporarily just on my bench here. But in production it's going to be mounted on the ATM machine. And that machine is going to have power supplies in it, so I'll probably put wiring with ferrules on it and use the terminal block instead in production. All these opto isolators are the wrong style. I'd be tempted to use the assembly service for this board. The only reason, the only thing I'd have to hand solder is the NRF radios, which is fine by me. Those would be easy. And the only reason I say I wouldn't mind doing this on the assembly service is because I absolutely loathe soldering these W5500s. And also the fact that this one has a lot of parts on it. What do you call it? The only other thing that I don't think they'd have is they probably don't have that in stock, but that's a QFN, so it'd be easy for me to hand solder. Oh my gosh, they actually have it in stock. Wow. So I could get that done. These MOSFETs though, I don't think they have. But these are easy to hand solder. Let's see. MOSFETs. For this board, no, I'm only doing 4 scanners, so I would only technically need 1 of them. Now, if I order through assembly service, the minimum would be 2 boards, and then I'd end up with 3 extra. But they're blank, the extra ones, which would be fine by me. The problem for most of the boards is the availability of parts. I know for the BMS board, the main ICs that are on it, JLC doesn't have in their repertoire. The other part is cost. Granted, my labor does cost something, but I'm being generous with my time in many aspects. So, yeah. Looks like they have a variant of the MOSFET in stock. Hold on. It's saying gate voltage. I better check something here. Well, is it just this particular type? Yeah, the scanner itself, yes. The base station, not so much. But yes, it doesn't hurt to have a spare. The scanner boards are less unique in terms of parts, so those ones I can probably get assembled. And yeah, I'd be tempted to get these assembled. The only thing they wouldn't be able to do is these MOSFETs and the NRF radios, but both of those I can do by hand. So one base station can do 4 scanners. Okay. Oh, yeah. Okay. They do actually have a compatible variant that I could get the MOSFETs done too. I'm curious now if they actually have the IC for the battery system. Even the printer circuit board. Is there anything unique on that other than the hub IC? That's the main IC here. That's the main IC. Let's see if LCSC has it. Oh, they do. Would you? Oh, hey. Would you look at that? I could get the printer circuit board done too. Save myself some time. The big part is it would save time. It's gonna cost a little more to get them to do assembly, but I have a feeling the time saved might be worthwhile. The only one that would... no, not really. There's nothing unique. The only thing I would worry with getting assembled boards is if you've made a mistake, you've just spent a whack load of money on the boards. Now granted, you've spent a whack load of money on the parts too. But there wouldn't really be anything unique on them that I haven't already tested. So unless I really screwed up and mismatched a pin, but I've been labeling everything, so the likelihood of that is quite slim. Let's see here. Open up the battery pack on my other screen here. One of the main chips is this one. No, they don't have any in stock. Now, it's not hard to hand solder that. And they don't have many of these left. Do they have the main MOSFET for it? No, they don't. So it looks like the battery boards I'd be doing by hand. Which is fine. I don't mind doing that one by hand. Wow. It's got a lot of parts that are annoying. It's all the capacitors and everything. I'd still be tempted to do them through assembled service, to be honest. But, wouldn't be hard to solder the ICs on after the fact. Yeah. Something for me to ponder over the next few days. But let's see if we can finish this. Actually, especially considering I'm not putting values in place, it very likely would be worth me worth me doing assembled service, because not having the values on these boards means it's going to take me longer to do them. I'm going to turn them off as I add the correct parts in place, so that I know which ones I've replaced and which ones I haven't. What? No. Remove that. Actually, no. I'm going to delete that. feel like I'm missing something. Ah, that explains it. Oh no, is it gonna crash? Crap. Ah, darn. Let's see if any of the backups have anything good in them. Okay. Let's try that again then. Set the footprint here. GST. These are 6 pens photocall. That. This is part of the Ethernet. Which, let's go back into here. power filtering. Well, power switching, I should say. Another MCP. And then goes over here. Let's save. And then crystal comes over to here. That goes with that one. That is for Ethernet. That. There. 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 Next to that. This goes to Ethernet. This goes to the buzzer. Terminal block 2.1. This diode is for power on that. This is the main power regulator, and it also didn't copy over the inductor. Inductor just there. This goes to here. Another LED goes to this one. LED for here. Resistor for here. This one is for here. And that one goes to here. This LED is the terminal block LED. Another one here. That is the power LED for that. That's a fuse. There's a fuse. Fuse. Another fuse. 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 Actually. Those fuses, I don't think I need them, to be honest. They're on signal wires, and I already have lots of resistors on that. And it's going to be shorted anyways in use for the signal. So it's likely to interfere, to be honest. Yeah. So this can be deleted. That goes to there. That is for that. Oh. LED here. That is for the barrel jack. This is for Ethernet. This is for that LED. Inductor. Ethernet. 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 Power LED. This is for power LED. Ethernet. 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 That is for there. Power. this one goes to here. Did I add? Oh, I did. Okay, cool. Just making sure I had the resistor for, this is the connection for the LEDs, and the signal line has a resistor on it. It's this one here. Last port is over here. Okay. Man, the features on that touchscreen. And the fact that it fits within the memory constraints. Oh my goodness. Of the touchscreen? Yeah. It's it is a darn good screen, that is for sure. Especially for the price. And the plus screen weighs even less. Mm-hmm. Thankfully, this board does not have as much of a size constraint as the other ones. Other than the fact that I'd like to keep it under 100 by 100. Because cost jumps up. Although granted, this might end up being a 4-layer board. So I think 4 layers is $55.50 before it jumps up in price. But nonetheless, I will try to save space where I can without being nuts about it. here, that 2. What is this one? This one is not one that I need. Okay, cool. So just this one last pot. thought I had a power LED for that. I don't appear to. So let's add one. And then come back down to here. No net found for symbol U7. What is U? Oh, there's the LED. U7, 5, 6. U7. Oh. Complaining about the thermal pad. Let's check the data sheet, but I think it's either a thermal pad or it's directly connected to ground. Well, it considers them thermal pads, so it shows it with the holes on it. So I'd be tempted to say it is ground. And ground is pin 17. So what I could do is actually edit the footprint. Control E. The solder paste pad. Pad 17. Save. Close. Do the same down here. Control E. That connects that to ground, and then what I want is, actually I'd be tempted to add LEDs to the NRF radios as well to know that they're turning on properly, but I'll do that in a moment. Actually, let's do it now while I think about it. Actually, realizing that resistor is way too small. No, way too low, 4.7K. So I'm just looking at the schematic here. Because that's the right size resistor, I can copy it, put it over here. This is gonna throw the numbers off. It did when I did the diode for the power regulator as well. It throws the numbers of them off because it does them left to right, up and down. But because I'm adding stuff, it changes it. But once I sync everything up, right, so I can go in and annotate that, save it, come in here, update. So J1 doesn't have a footprint assigned. So J1 is where? It's the TFT screen. So footprint. pins is that? I think it's 8. It is 8 pins. Yeah, I think I'm using vertical on this board. 8. And then, oh, I closed it. Why did I do that? And then I come here and update. Okay, no errors, cool. And then all I need to do is come back here and annotate schematic, clear, redo annotation, close, save, update. There. All the numbers are nice. And so the TFT screen also uses SPI. So ideally, I'd put it near the SPI connections. And let's see. So that's everything pretty much sorted. It just becomes a matter of making things nice and neat. So if we do it like this, and then we have the 2.1mm jack. I could put power. I want power closer to both the Ethernet and the ESP. Ethernet because Ethernet pulls a whack of power, and so does the ESP. So oh, nice. No, they still have to come over here, which isn't too bad. I think I can make that work. Oh, need to. Nope, that's right. It comes over. CS. Oh, here it is. There's the SPI over there. And then the NRF radios also have antennas on them. So ideally, these are near the ESP. That can come over here as well. And then let's see if I can do the power stuff. Pretty sure that diode is backwards. Yeah, it is. So that should be 2. That should be 1. I think. No. Yeah. Ah, there we go. Just needed to update it. So power comes in. Goes to the diode. We can have the LED next to it. Right. Best way to do this. Actually going to be to rotate this because power needs to come down to here. So this is going to rotate. And what I'm going to want to do is I can put the LED there. Wish my mouse would stop doing that. Double clicking. So that's pen 1. That's pen 2. Sync it, save it, rotate. Turn that off, and then what is it? Actually, I'm realizing I might want to go back. Don't really need it as much as... What project did I do it on? I think the battery pack has it. Yeah, see on the battery pack, I labeled the power output. I did not do that on the printer board. That. for this. Put it here. Oh, I got these backwards. Yeah, I wouldn't necessarily need... So on the printer board, if I open it, there isn't too much space to put things on the top, but the back side has a whole bunch of space. And so if I rotate this, it has a whole bunch of space. It probably couldn't hurt to leave some labeling of what the various things are for. So I'll probably go back and do that at some point. Leave a note. And then that can come in like so. So power can come in. These are connections for that. Yes, I've done that already. The cables do match. And that's part of the reason I think adding the labeling can't hurt, is that if somebody else comes along and is poking at it and maybe grabs a new cable for whatever reason, it'd be very easy for someone to grab a crossover cable and not be paying attention. So yeah, being essentially being mindful of that can't hurt to add. I'm gonna put the debug connection there. Switch something. Which one? Oh, this? Oh yeah, no, this is a power input. It's fine. The other ones are, I've matched all the connections. The only thing I had to redo on the printer board was I switched from using a vertical. Oh yeah, the VN and ground. Yeah, no, this is fine. That's why it's labeled, so that you know which one's which. It's a terminal screw block. For initial testing, it's going to be easier for me to use the 2.1mm jack because I have a 12-volt power bar sitting here. But the final installation will have it attached to the ATM machine that I have to build. And that ATM machine will have power supplies built into it, but they're going to be the not DIN rail mounted, but DIN rail looking mountable power supplies where they have screw terminals instead of just a power lead on them. They'll have screw terminals. So I'll be making a wiring harness for that machine, and thus it'll be easier for me to use the terminal block for the production installation. Buzzer. Probably gonna put the buzzer here. There's going to be a few ways I can do this. I can possibly do it like that. Want to make sure that I can run all the traces that I need to. I'm going to see if I can do this on 2 layers. If not, I'll do it in 4. Power. Oh, it's the signal. I was trying to figure out why this was labeled NRF power. It's the signal to turn it on. That's handled by some MCPs. Now this is a reset button. Now that connector should say debug. And we got a quick connector, which can go here. This stuff. So where does IO0 go? Oh, it's all the way on that corner. Okay. In that case. So the state for the LED. Could put LED here. Or I could do this. I think this makes more sense. That's gonna make more sense. And then put capacitors in place. This resistor. Here. Turn that off. Now, this is going to have lines coming over to there, and one of the pins over here is IO0. So the better thing to do would actually be to move this to here, and then 3.3 volts can come over to here. The reset button can be here. And then Actually, let's change this from vertical to quick. And then update. Change that to silk screen. Rotate it. Yeah. And then there should be these are pull-up resistors that I can put in place. And then the wire for the LED, could do it like this, but I might need space for vias. So if I do it like that, come out to there, down to there, from here a via over to here. Do you like my thought process on organizing this stuff? Is it boggling your mind yet? Especially with the fact that I'm doing multiple boards all at once and thinking of how they all interlace with each other. Now, these ones, so one of these goes to IO0. But it has 3.3 volts on it, so the best thing to do would actually be to place it over here, where I already have 3.3 volts. Yeah, so I can jump 3.3 volts around all this. Give it a little more space for that silk screen. So 3.3 volts comes across. This goes to IO0. IO0 comes all the way back over to here. And then this is for the reset line. No. IO0 is different from reset. Reset's its own thing. IO0 is, for ESPs, is what puts it into bootloader mode. Just hitting reset just causes a reboot, but holding down IO0 while doing a reboot is what allows you to flash into firmware. What's this used for? Ah, this is the pull-up for reset. And then leaves us with the MCPs and the power for the actual scanners. And this is what does the charging. So, what's the best way? Best way to lay this out. Power. Thinking best way is gonna be to do it like that. So like that, and then you have a resistor. That resistor feeds the opto isolator and feeds that resistor, which feeds the LED. And then take in power, connects to that. I don't want to move this back. And that way I can do one giant thing of power. I think, yeah. That should work. It should work. Rotate that, take this, what I do is come into here, draw a line. Oh, I don't think I got that straight. Let's snap a new grid. So that's straight, and then snap another line. And then go another line. Let's make it a different color. Let's change. Okay, let's see. that's what's needed for that. Then the power. Let's align it to pin 2. There. That is that. I'm gonna leave that line there for a moment. I'm gonna go through here, change all this out. I'm gonna need to figure out what fuse I want to put into these, and I'll have to make silk screen for that. Probably gonna put a 4-amp fuse in it. Granted, information like that will also be in the manual. Actually want to turn that on. What? Oh, they're all the same name. That in the schematic. What? Oh. Accidentally turned off numlock. Let's try. 1, 2, 3. You know what? I'm actually going to turn it on right now so that I remember to edit it. Or at the very least it's labeled fuse, so it's obvious what it is. Oh, I actually need that turned on. There we go. Now, okay, let's condense things. I'm gonna leave that. Actually, put that off to the side. And then should be able to get a little closer. Forgot to turn off some ports. There we go. And then should be a matter. Hello, Ben. I was wondering when you were gonna come say hello. It's going pretty good. I'm working on circuit board number 3. Hopefully you get this. This one is the base station. So it's got the connections for charging. So these would go to pogo connectors in the base station. And the scanner would have one as well, obviously. And then attached to these pogo connectors, I'll have cables, and the cables will go to the connectors here. And so when a scanner is present and you're not holding the scanner, the ESP will turn on the power and start charging, and then display status on a TFT screen. So I have a connector here for screen to be wired up. Oh yeah, these pogo connectors are great. These are really nice. They're gonna work pretty good, I think. I think it's gonna give a nice professional look to it all. Ethernet connection for the ESP. So it's gonna operate in one of two ways. Either I'm gonna be allowed to use Wi-Fi on the barcode scanners, fingers crossed, in which case you can send this controller updated information of the scanners, battery information, whatnot, and it will display it on the screen, along with idle and the ability to recall a scanner. Basically, make it ring like a telephone of, where are you? Or if I can't use Wi-Fi on the scanners have NRF radios. So these are NRF radios here, and I put 2 because I'm kind of thinking one would be set to receive data and the other one would be set to send data, but I'm not entirely sure how that would work in code, or if that's even possible to do. So I just put 2 just in case. I can turn them on and off if needed. I don't entirely have the answer for that, other than there are some security concerns from the IT department. I don't blame them for having them, but I'm trying to see if I can, because I'm putting in my own server, I'm trying to, and that server will actually have 2 networks, one for all the stuff that's inside the gift card machine, because that's where the server would sit, and it would power a terminal screen on that gift card machine. It would connect this base station to MQTT, along with whatever stuff I design for the mechanical of the gift card machine. All that stuff needs to be networked. And so because I'm going to have that internal network to the machine, I'm trying to see if I can add my own Wi-Fi access points, so that it would be completely isolated from the network. And then there would be a second network on my server, and that second network would actually be a website server. Still trying to get permission to do that, but I'm gonna keep moving forward as if I can do it the way I want it to, but plan to change it if I need to. So if I have to use the NRF, then this would also act as an NRF to MQTT gateway. That, and while one method might work for this client, it might not work for another client. So again, having the hardware compatible, because that was one of the questions even my current client asked, was if we decide to change this like one minor thing, how difficult is it going to be? And said, well, I've pretty much stuck every piece of hardware you could want into the thing, so it would only be a matter of changing software. The only piece of hardware I'm not putting in it is the ultra high frequency RFID, for the sole fact that that equipment is expensive. I haven't seen anything for that stuff hobbyist level. Almost ready to draw the board outline and see how big this thing's gonna be. Oh, I love it. Absolutely love it. Oh, no, I mean ultra high frequency. I'm gonna put the PN3... So this one here. This is... PN532 or something. I'm gonna put that one in it as well. No, I'm talking like the 800 megahertz stuff. But yeah, no, I love KiCad. The only thing I want to do is build a macro keyboard at some point. That'd be handy, because if I build a custom one, a lot of things that I do multiples of. So like, for example, I'm turning off the silk screen for this. It'd be nice to make a macro key that automatically uses like tab or something to go through and turn off what I don't want. Pardon me. Yeah. Yeah. So I'll show you with this one. I click E, which brings up this menu, and then I turn them off, and it changes them. Say I wanted the 1K to be part of the silk screen, but I don't need the RN1. I could go hit E, click it to be off, and then I can go in and change the layer that it sits on, so that'd be on silk screen. So now that would get shown on the circuit board. And I can go turn it off. The other thing you can do is the other thing you could do is hit Control E, and it brings up the footprint. Now with this, you can this would edit it for only just this board. And just that part. So like if you wanted to make a minor adjustment for something, you can do so as a one-off. Yes, that was part of the reason I chose it, is because it also has the NFC capability. The only problem with its NFC capability is it needs the library needs work for it. It takes a good 4 seconds to... The fastest I've gotten is 4 seconds to read a tag with memory in it. R to rotate. I think so, yeah. It's trying to read all of the data in one chunk. Now granted, I haven't tried it on SPI communication to see if it's much faster, but yeah, it really would. The initial library I tested, though, was like almost 10 seconds for just a small string. I can only imagine a larger amount of data on a tag would take a good chunk of time. Because initially I was going to program RFID tags with the exact inventory information, and it was just, even getting it down to 4 seconds, I was like, that's going to drive users nuts having to set out a box for 4 seconds for it to scan. So then I was thinking, oh, okay, then I can make a database of the tag IDs because I could scan those in less than a millisecond. No, I didn't try microseconds, so I have no idea how low it is. I just know that it's 0 milliseconds is what was reading out on the Arduino. So that was one possibility. But then I was thinking about it, how like you'd have the RFID tag, but then you still have to write what the item is so that people know which tag to scan. And then I realized, at least for initial uses, it's probably just faster for me to use the printer and have it print out an asset tag with the QR code and the information right on it. So my initial demonstrations, that's what I'm going to end up doing, and I can always adapt or change things per client needs if needed down the line. But at least the way I have it set up for now will be quick and fast enough. For how cheap the barcode scanner is, it is shockingly effective. Now, let's see how big of a board this is going to turn into. So grid size, and let's come down here. Oh, let's put it on the edge cut layer. Nope. There. So, set it to 50 by 100 and see how we do. Feeling it's going to be a little wider than 50. Oh gosh. Yikes. I really don't want it to be larger than 100 in any direction. Right. So let's move this stuff. Let's turn off the nets for a moment. Let's see what I can do here. That like that. I'm gonna move this terminal block back. That I could move it back slightly. Actually, it's probably best to move it back to match the Ethernet jack. Otherwise, any case that I design for it is gonna look a little weird. Though granted, I don't plan to use 2.1mm jack in production. But somebody could. If you're not building the full machine that I'm going to build, then you might just have a base station on its own. In which case, the 2.1mm jack would actually be useful. Now, put that like that. Move this over. And move the TFT connection over here. Now, 100mm. Would be set the grid back to 1. Oh man, that's big. Definitely not doing 100mm. So, we'd still be tempted to have this over here, just for niceness. I'd rather it be over here. Let's make a note where that line ends up. Yeah, Flipper Zero would be nice. I'd wonder if a Flipper Zero would have read these staff RFID tags. Oh well, I found a reader that works with them. It just took me a while to get my hands on them. And I only have a sample. I'm gonna need another 5 more of them. They should be available September, if I'm not mistaken. Now I could always put these off the edge. Yeah, no worries, Ben. It shouldn't take me too much longer to do this one. Once this is done, then it's done, and then tomorrow should be the well, after John's stream will be the last circuit board, and then it's bill of material time. If I do one there, doesn't fit nicely. Tempted to move that there. Move this over here. Move this. There to there. Where does this go? Oh, okay. So this can go here. That can go there. That can go there. That goes there, that goes to there. That over there. Let's turn the nets back off. Save. Move this over here. I can move the button, and then I can move it over even more. Actually, rotate the button like that. And then this connection, I want the edge. Right there. Still can't fit the radios in. There's got to be a better way to do the layout of this then. Let's see. If I rotate it like that. Yeah, possibly. And I do that. Move that. If I do something like that, I might be able to fit one here, fit one in the corner. Well, let's see. So if I move that, can I do this? That's cool. I can do that. Just to test it at least. So that I don't have to move them all. But if I move one like that, and I move one here, fit one more here, and then fit one here, and then videos can fit like this. That can work. Be nice if these weren't hanging off the board, but not gonna matter. I'm gonna use the external antennas on them. Although I wish you could remove the actual antennas on them. If I only needed one, it'd be great. But I have no idea if what I want to do will work with one. So I wanted to put two in place. Do it like this. That can work. That way it's self-contained to that size. Cool. Just have to mimic that with the rest of these. Yeah, I'm gonna have to fit some mounting holes on it. Let's go into my schematic and add that now. I can add the logos while I'm at it. So M3. We can annotate that schematic. Save and import. The logos are probably going to have to go on the back side for this one. Let's see here. Import the text from the old one, or the other one. I'm trying to keep the text looking the same between them. Yeah, if it was my own board, normally yes, I would try to squeeze things on the top. But because it's kind of a collaboration type board, I'd rather both the logos always be visible, so I'd rather put them both on the back side where you see my company and then the project attached to it, so that no one's ever questioning what something's a part of. Dual advertising at the same time, essentially. Now this one I can fit in this corner. Six and set the group to 1 millimeter. And I would ideally need at least 2 mounting holes. I'd be tempted to fit one in that corner. Not 1.6. And if I could fit one dead center, that'd be nice. 50, 60, 70 is dead center. 6 x equals 70. Just my luck. If I fit So this is 100 millimeters wide, and once you start going beyond 100 millimeters by 100 millimeters, the price jumps a fair bit. So if I can stay under it, I want to stay under it. So that's center. Now with this circuit board, what I probably could do is because I don't plan on, so it has, where is it? List. Yes, I can go downwards. This section here I could use. I'm just trying to keep it compact if I can. But so the one option is so this is the board I plan to use for the NRF radios. So it has the option to use this external antenna, the onboard antenna, or an external antenna. All the connectors are vertical. They can be wherever. They don't need to be at the edge. I'm just trying to orient them in a way that's easy to run the power to them all. So the one option would be to physically take a Dremel to this and cut off the antenna. Which one? These ones? Oh, right there, 90 degrees. Oh, so they're facing this way? Yeah, initially I was trying to fit them all on this edge. But then it was running out of room for this. What I can do is do that. Because even no, I actually don't need Wi-Fi on this ESP because I have Ethernet, and even if I did, this has the external connector. Haha! I could fit them like this. Let's turn on the nets for a second. Figure out which one goes to which. That goes to that one. And this one goes to this one. And then these. Oh. can be put one like that, and this one can come here. The good back. Actually, the one thing I'm realizing is I should probably double up this diode, because if you try using full power, terminal jack will handle 10 amps. This would be limited. Yeah. I would definitely need the firmware to know the power capabilities. That's a potential problem. Do I have any spare I/O? I do have spare I/O. So I'd be tempted to add the ability to know which input you're using so that it can send a command to the scanners to back off on charging current. So what I already have in place is I have LEDs that I'm using to monitor. Yes, I could do a resistor divider, but what I'd rather just do is what I do with these fuses, which is use an opto-isolator. Because then it's a simple on-off signal to know that you're powering through whatever method. And I could move this over and fit one for that. But that should be pin 2. That should be pin 1. Update. That way I'm guaranteed to handle the current coming through there. And let's update this. Actually, kind of tempted just to fit this one like this, just because everything will look a little nicer. Oh, accidentally moved the edge of the board. There. And then that gives me plenty of space. And I can fit the two NRF radios here. Curious. What uses less space? Doing it like that, or doing it like even if I move it up, you don't gain much, no. Because you'd have one like that, and then you'd have this one like this. And then the mount hole right here. Yikes. And this right here. Nope. I think I like the idea of the NRF radios being along the bottom better. So that puts that like that. Make sure this is at 74. Should be centered. Yeah, you would keep ground fill away from them. But it won't matter too much because I'm going to use the external antenna on them. The ESP has the external antenna on it. It doesn't. It's not the added antenna version. Here, let me finish this off, and I can show the 3D version of it. Oh, Keith coming in with the knowledge. Yes, it would. Even with putting the MCPs in, I'd still have plenty of space for the logos. Indeed, QFP. Wanted to save space, and I love soldering QFP. They're really nice to solder. Although I might not actually be soldering this, I might just get it assembled. Well, don't need that fourth mounting hole. Save, delete. Let's move this. Oh, plenty of space to do stuff. So I still have to add the sense. Actually, what I could do is so in the device setup, I can set it up similar to how I did my Smart Hub, where you tell it the amount of power it has available to it, and then I wouldn't need to know which jack you're using, because if you're trying to feed 15 amps through the 2.5 millimeter jack, then well, that's on you. And I can put warnings like that into the web browser UI for updating things. Yeah. But yes, actually, you're probably right. At least for this client, I'm the one doing all the setup work. But for the moment, let's just position this. And set. Oh, no. Oh, crashed again. Jeez. I think I've saved it recent enough that I'm gonna get lucky. We'll see how far back. Yep. I got so lucky. White, purple, nope, purple, no, white. Save, and 3D model. There we go. I wonder. Yeah, I'm a very habitual Control-S person, so thankfully I don't lose too much very often. But we can see how everything fits. That is so nice. And no, I'm not actually going to be using these absolutely piece of junk blue terminal jacks. No. I use the proper ones. I want to see something. Did I happen to save the part number? Oh, I saved a part number. I don't think it's the exact fuse that I want, at least for this one, but I did save the part number, so let me see if I can find the 3D model for it. That 3D model is just a black box. Awesome. Download that. Open. These LEDs? No. This is simply a debug LED. Yeah, it's simply for debugging, because they're tied in after the fuse, and wired up same as the opto isolator. So obviously if I open it, because it's not charging, but I see the light on, or it's not reporting proper status or whatever, like, then I have ways of visually seeing. No, everything's going to be done through the LED port and NeoPixels, and I can do nice animations and stuff as things are charging. Because the config for this would be to tell it how many bays you have for charging, so 1 to 4, and then you'd have you tell it the printer's ID tag, so that what would happen is the ESP would directly start trying to pull information from the scanner, so they would have communication between each other. And then from there, so you'd also have a rotary encoder, and if you're not doing anything with the rotary encoder, the TFT will just show base information where, so if you have 4 scanners enabled, it would show 4 different boxes, and show you if scanners off the station, would show you how long the battery is going to last, if it's on the station, it tells you how long till it's charged, or if it is charged. And then if you use the rotary encoder, it would switch the screen to one at a time, and give you the option to ring the scanner, which the encoder is both a rotary knob, but also has a button on it, so that you can push it, and then it would send a signal. And it would also show in the base mode. It would also show if like the scanner's idle, or if someone has it logged in or whatever. But it would only show however many scanners you've actually configured. If you're only configuring 2, then it would only show 2. If you configure 4, it shows all 4, and etc. for various combinations. What I need is that. Now, is that fuse something I inputted or exists? Ah, it exists already. So, footprint editor. And that is under fuse, and that is a little fuse nano 2. 3D model. Fuse holder. Ta-da! Why does that seem slightly large? Is that footprint slightly wrong? That's what I want. Ooh, that footprint is wrong. That's not the right size. Good thing I'm checking that. It's weird, it should match. It's supposed to match. Weird. Oh, that's what it is. It's to match the fuse, not the fuse plus holder. Yeah, personally I'm gonna use the fuse and holder. Crap. Because the printer has the same part on it. So, what I'm gonna have to do is make a new part. Let's go. Symbol editor. New symbol. Fuse is F. Oh, it's not what I wanted to do. Reference F. Oh, I don't need that. And then let's delete that. Delete symbol. Where's the other one? Who the heck? Oh, there it is. Huh. Okay, so there's that, and then import footprint. Don't need that. I can leave that. Let's see. Upload the 3D model. Aha, there we go. Save. Close that. Link the two together. Okay, so let's go back into here. Oh, yeah, the star is to tell the program it's to link the number, so it's F1 is fuse 1. That's why it does that. So what I need to do, right, I should go back in. This is not the exact fuse I'm going to use, but it's part of the same lineup, so if I ever need to find it again, although granted I saved the mouser port number, but I'm going to save one of the LCSC port numbers on it. I'm just gonna do it off screen. Oh no, it's gonna open up over here. LCSC. I don't need to show it. Save, close, and then you can come back through here. Move all of those fuses. Should close the 3D view. Add part. So that's that part in place. Save. Can annotate it. Close, save. Come back to here and update. What? Oh, they're the same darn size. What? I must have been looking at the wrong one, because that's the same size. All that updating and worrying, and I had the right one to begin with. I must have been editing the wrong file. No idea why it has a dot on it, though. Let's go into the footprint editor and change that. Don't need that. Well, let's fuse 2. I'll leave those on for now. And it's over here. Well, let's just take a look at it in 3D mode. Oh, that's awesome. That looks really cool. So, perfect. I have the printer board open as well. So let's fix the fuse in this one. Plus, having good renders will be nice for the documentation that I put together. We can put good photos in place and put arrows and point to things as I need to. Should really add a fuse for the printer, I think, but I'm gonna leave it. Did it update? Ah, it did. Cool. Okay, save that, close that, and back to this. So, move that over there. Move that out of my way. And save. I'm gonna come back over here. 10K across that. 10K on there. Yeah, okay. So we'll copy this. Let's see how I'm gonna fit this in place. What I can do, so I can move that over. Oh, did I? Oh, I did. Thank you. Oops. There. I can move that out. And now I can fit this in place. So. Turn off the port number. goes to there, and then goes to ground and ground, and then that's your signal. Technically you'd only need the one, because if this one's false then and you're reading status, then this one has to be true, but just to be safe I am going to do it on both. Oh, accidentally opened a window. Let's see here. Oh. Power from here. Yeah, but I'll put both in just to be cautious. Do I really want to? I don't think it's worth the poke cost. Oh, what do you think, Steven? Do I spend the few extra cents and add it to both, or just use the one? I'd be tempted to just use the one, because, yeah, really don't think it's worth the extra putting it on both, because if it's not on, then you're using the low power option. Oh right, I need to actually hook it up to an I/O pin. High power state I/O 13. Yeah. It'd be redundant, but in a non-useful way. Yeah, it's set to the right footprint. I really wish they made like opto isolators like this, but that were for this type of usage where you don't need the big isolation and the voltage. Like I think this one's for 5,000 VRMS, but like, I don't need it. I'm not really using it for isolation. I'm using it for status, because these things take up a lot of space on a board. These are 10K. So the reason the printer board has 18K is because the printer board is running at 24 volts. This will be running at 12 volts. Although even with running at 24 volts, I think it's still fine with a 10K resistor. But no, I plan on running this one at 12 volts. Oh right, I need to annotate the schematic. Clear, annotate, close, save. Move that to my upper screen. And there. So that's the status. Oh, come on. Trying to decide here. Actually, do it like that. That should do that. Yeah, it's only more of a status thing. You'll still see it when it's lit up. Trying to make the running of the traces easier, that's why I'm putting it like that. Now, to run a lot of those traces, I need to name them. So... that should be VDD. That's terminal positive. That can be a trace. That's a trace. Oh, I need, it's VDD. What's the other one? One. Fused 2. Oh. Fused 3. Fused 4. And then the reason I'm moving that is so that I can make room by the MOSFET here. Because I need a name for it so that I can do the polygon. think this is the most number of boards I've had to do with fill. Normally I just use traces for everything, but for this it does make sense to use the fill inputs. FET 3, FET 2, and FET 4. Save and move that out of my way. Update. There. So let's start with power. Nope. Need to select the copper layer first. Top. Barrel positive. Now, the better option is going to be to move this over. Actually, move it this way. Who's messaging me? Ah. It's the notification of John's live stream tomorrow. Depending on how tired I am, I'll, well, almost guaranteed to be watching, but I'm hoping that I'll not be too tired and I can finish the design of the screen board tomorrow, or at least start it. I might not finish it, so that one's gonna take a while. And what I need to do is, alright, need to edit some of the settings. Corner smoothing, 0.5 millimeter, priority is higher, and I need to go to mils, 8, and 30. Come over a little. I'll probably make adjustments so that this can connect with copper for the ground. This can come down. Let's see here. Yeah. What I could do is come all the way across, but I don't think I need to. Plus, I need power to come around. Actually, better option is going to be to rotate this. So that power does not need to come around. And instead, I can do what I wanted, which was extend this out. Just because it's going to look nicer that way. Yeah. So that's the power input for that. And then what I can do is terminal plus. Goes round. Covers that. It's pushing it. Yeah, and then I'll probably move that over and I'll fix this down here. Tempted to go a little further with that there, and then this I can actually come out more. Move that back over. Oh, let's fix that silk screen. And I'll adjust that in a moment once I put the power rail in. And let's fix this one. So let's start the power rail. Yeah. Nope. Top and there's the power. Oh, I shouldn't have done that. But what I'm going to do is actually move this over because I want the most direct access for power from these. Oh, what? Oh, why would it do that? I know why. My mouse was being wonky. Okay, so want that. Not too worried about the capacitor, but I want that connected like that. The capacitor. Yeah. That's what I wanted from that. And then I'm gonna slide this out. So ground should be able to fit around that. And then not sure if ground will fit through there, but I'll let it try. Same with this. I can let ground try to fit its way in. And then that to there, to there. So hopefully ground will be able to sneak its way through there. That's that, and then now. There's the power rail. Actually, should increase this size. And then we can come in here This would be fused one. Oh. Doing it for the wrong board layer. But I'll fix that in a moment. Don't know why it's... Oh, because I've selected the bottom layer. That's why it's defaulting to it. That's that one. And then... Actually, what I've realized I can do is I can probably copy and paste these. If I select that... Oh, I can. Oh, so I can lay out just the one and then copy and paste them, and then all I have to do is change which net they're a part of. Cool. So I can save myself some hassle. FET 1. Now the only issue is going to be getting the signal for these MOSFETs out. Let's see. 6. So let's see here. Ooh, I can fit it. It adjusts. Okay, that's not bad then. If it's auto adjusting for it, I can live with that. Only thing I want to fix is that. But if it's gonna auto adjust to this trace, that's fine by me. And then the only one left to do is a power. Scanner power. cover it for that. So all I need to do now is select select, copy, and paste. Gonna need some manual adjusting because clearly these aren't the same, but will save me a lot of time. So this should be fused to FET 2 and scanner power 2. And so on and so forth. Oh, no, wrong one. That's wrong. Let's see here. So the edge of that was... yes, it is just past 6:30. Coming on 9.5 hours of streaming. I really want to get this done. 2, 3, 4, 5. Oh gosh, another hour? So our daylight savings was a while back. So that pushed John's stream an hour more. So it might push it another hour. So it ends up shifting 2 hours each year in total. Let's see here. Yep. It is going to be an extra hour later. Maybe I won't stream tomorrow then. I'll get probably wake up, watch John stream, probably go back to bed, or at least take another nap. If I do anything, maybe I'll start going through the various folders here and start filling in the bill of materials. And then the night after, I'll string the last board. It's spring forward, fall back. That's how I always remember it. Yeah, I like the fact that I get to pick my own schedule for things. Not have to work a standard job and always be worried about time and money. Well, granted, I'm worried about money anyways, but time is nice to not always have to worry about it. Sometimes I wish I could handle a standard job, but combination of things, it ends up driving me nuts, and doesn't do me any good if not making a paycheck, and then that's why. See, I could just leave it, because obviously it would still work, but I know it's off. It's gonna drive me nuts if I didn't do something about it. Okay, so there's power to everything. Well, at least this stuff, the main incoming power. Let's go 20. So I can do that, that. Ah. Can edit this. That can connect like that. looks like a lot of space there compared to all the others. Yeah, it really is. I did not space these out very well. 1, 2, 3. That has a lot of space to it. Space 1, 2, 3, 4. There. Now they're pretty much all identical. Yeah, that's right. Oh. It's supposed to be like that, yeah. There. I can go back to putting my traces in. That goes like that, that goes like that. There. 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 Oh. There. Okay. Ground. I can put these in. Set it at 14. Thank you for hanging out, Keith. Enjoy your day as well. Shouldn't be too much longer for me. And probably watch John tomorrow, and then the day after will be the last board design. And then I'll probably start the 3D modeling. sure ground can get its way around. That almost rhymes. This one here. It connects to here. The reason I'm going so wide is because I'm gonna have a via in here for ground to connect to. Can't hurt to do that now. It is a 40. It's a large one. Via hole is 0.4 millimeters, diameter is 0.8. It's a fair bit above the minimum spec. Oh yeah, it is huge. Oh, that's big. Oh, sorry. 0.25 drill and 0.5, yeah. Yeah, the specs I use are really old PCB way specs. And I just haven't felt the need to upgrade yet. Ground for that. And that's connected, that goes to that. Goes like that. Da, da, da. This stuff. 3.3 volts over here. Upgrade that. Let's see if I can do a 14. Does it need to carry current? Yeah, I got a quick connect over here. So I am going to want current capacity. The best way to do that is going to be to come around this way, I think. Yep, that's what I did on one of my... I'm referencing another... Yeah, I'm still using 0603. That way if I have to do rework or manually solder, it's nicer to work on. If I had the constraint where I actually needed to change it, sure, but it don't, so I'm not gonna chase it. Okay, so that goes to there, that goes to there, to here, here, connect, and there, this comes to those. See if this is gonna fit. It does fit. Oh my goodness. To there, and then how did I do this? This one comes over to here. And then comes across. Two. Pin 2 comes here and put it via there. Pin 1 comes up and around to come on. To there. And then this construct via this goes to another via. I'm gonna let me place a via. Oh. Was actually coming out more with this. But do I need to? No, I don't. As long as I can fit the trace. Oh. As long as I get ground through there. Yeah, okay. Okay, and then yeah. Oh, it's gonna do the ground fill, but I'll add stuff if I need to. No, I don't really need to, but I like it going through everywhere. This makes it nicer, rather than relying on a thermal gap to a thermal gap. Let's see here. So this one goes across to here, and then this one comes to here, and then TX. This one. That's Ethernet. Just make this a little more compact. There. And then power can come up and around. Yeah, so let's do the power. That's the LED connection. And this one. It comes. And then power. These don't need a lot, so I can do this. .3 volts. Oh, this mouse is driving me nuts today. Oh, did it again. Actually, I'd half wonder if I'm just better off putting a via here for this ground. And running this like so. there, to there, to there, to there, like so. That connects all of that together. So let's move that down. Because this is an inductor, so it can't hurt to have it covered on all sides. And then I can do that for the capacitor. And be tempted to move this over. Add that. And that way more current can flow, and I'll move this over as well. I can make this wider. There, that should handle all of that. Not expecting ground to need to go through there, so I can move this back. Oh, my mouse reset itself. I wonder if the battery's getting low on this mouse. Normally it complains to me before it has an issue. Actually, can't hurt to go like so we got ground. So the only thing I can change here is put that in place. for that, and then here that'll work for that. There's 3.3 volts, and then grab a big trace from there, run it from there, and then I can come from there and then what I need is to come to here. I'm gonna try putting a new battery in this mouse. Not ideal, and the reason for that is because now usually I do use a via for reset anyway, so I'll leave it. So it isn't unusual for me to do it that way. Do it like that. And then can build off of things. Reset. Oh no. See, I live somewhat nearby to the fire department and the hospital. Thankfully, and I live near a major highway, so like if I'm outside, you can hear the highway. Like, it's loud, the amount of noise you hear from the highway. But interestingly enough, the house is rather soundproofed from it. Almost to a rather impressive degree. What I'm realizing is if I move this like so, I can run a trace straight from there to there. So I can do this. and I can still get ground in through there. If I do that, right here. So if it's right here, I could go around this way, but then you're cutting off ground in a few spots. So by doing it here, if I move this slightly, ground can come in through there and can come out there. Granted, let's see something. If I do this, and what I can do is do it like this. Nope. Okay. So if I do that to there to there, from there to there, there to here. That's better. And then that can come across to there, and that to there. And then this gap is no longer needed. Power goes to there. Oh. Darn. This crystal needs to move. Fun part is going to be via for that. Put a via there. If I could fit via there, via there. That should work. And then let's get this big trace back through here. I'm not sure what I can do. Yeah, I could probably do that, couldn't I? I could do that. The crystal? Oh, yeah, still gotta come all the way. Well, I guess I could go through it. Yeah. So we do that. Like that? Is that what you were thinking? Yeah. I can agree to that. And then now I got tons of space for this big power trace, but you're not wrong, it's probably just simpler to just across there. There, and then what size did I make this? .24. That is that. Can simplify that. I'll need ground to come in for here. And I'll probably place a via there as well. Ground will come over. Oh, this mouse keeps resetting itself. There's something wrong with that thing. It's definitely reached its lifespan. My goodness. When I get paid, I'm buying a new mouse. My goodness. Although I'd wonder if pulling the USB dongle and resetting that would help, but well, I feel like finding out at this exact moment, only for it to not reboot for some silly reason, and then I'm stuck without a mouse. Oh right, this has 3.3 on it as well. And yeah, that's those main traces. Let's do, what in the world? How did I get these mixed up? Looks like I did. Oh, good thing for the power bus. There. is the power. Ground can work its way around. I'm gonna put a no fill here. Not that I plan to use the onboard antennas, but figure it can't hurt to put a keep out zone. There. That's that. What else? Only thing really left is a bunch of signal and spy lines. Let's see if I can't do the traces on these. Yep. I think I have 4 items, which isn't too bad. Oh, come on. Really? There. That's better. Yeah, so 1, 2, 3, 4. Yeah. And then for this, put a via in, via here, via let's try that again. So via oh, I have to start from the center one. Oh, if it could stop phantom clicking, that'd be great. Via. And then via. And via. And then 1, 2, 3, 4. Oh, what? I think I got it too close. Oh. To go up. There we go. Now, it needs 3.3 volts, so I'm wondering if I should position it like that. And then this one needs the same for these. Fix that in a minute. It's doing a lot of phantom stuff. Like, it went to the underside. The keyboard shouldn't be doing anything. Let's do that. Oh, let's try that. Like, I didn't click anything. Like, what? I'm gonna have to do a reboot on my computer. Okay, and this was 24. More than enough. Oh, nice. Just need a regular signal for that. And the second one is this one goes to here. What? Yeah. And then there's a 3.3 volt rail there. Oh, that is there because it's part of the address. And then there's one over here too. And the I2C lines. Oh, I did miss the decoupling capacitors. No. Silly me. There's one. Good call, Steven. Tools, annotate, clear, annotate, close. Save and update. Supposed to go with U8. Which one's that? That's U7. So this one should be with this one. This one can go over here. Actually, what I can do with this one is have it right here. Where does the I2C connect? Oh, it's all the way over there. So, best option is gonna be that stuff has to go up that way, so go to there, across to here. I'm not sure. I'm gonna try it as it is for now. So that stuff goes there. The only thing, well, actually, I could change the pin designations for SPI and whatnot. I could move things around and use other pins. But I'm gonna leave it for now. Yeah, SPI is over there. Let's see. Yeah. No, I'm gonna leave it for now. So those come over to there. Which this might end up being a 4-layer board. Actually. Oh, that's not a... that's a larger... Let's try that again. this to here. So that's the I2C connected. Oh, I'm definitely gonna need more layers. I can already see it. Because I'll have SPI coming over here and then SPI coming across. Yeah. I'm gonna need more layers. These lines can all come across to there. How's the render looking? 3. Not all 3. Over this way? And then under? That could work. Still gonna need more layers though. Especially because I have to come over. Actually, let's keep trying. No, because I'm gonna want sufficient grounding for everything. Because even with all these traces, actually, it might work. Let's see. And reset. Where does reset go? There. There. That one's all the way over there. What? It's this one. This one comes over here. What's pin 9? Wonder if I can move them up. Make them all in one spot. Pin 9 is IO16. So what's this pin? Oh, it's the chip select. Okay, let's move. TFT chip select. So you got reset. Then you got DC, chip select, and then black light. can come to the TFT. It's up here. Set DCCS. Okay, and then we come down here and update this. That keeps all these lines over here. This one? Maybe. So come over to here. Oh, I can fit it. Oh, yes. Whoa. The 3D printer slash China tech company Elegoo just sent out their email announcing their laser engraver. We've got a 10 watt and 20 watt laser engraver that they're going to be selling. I move this over to here. Move that to there. Move that. You're right, I might need to still move this over for all the vias to fit. I think this battery's dead too. Seen my mouse flash at me a few times. Gonna be annoyed if I've just had multiple dead batteries in this mouse, and that's why it's been acting weird. See how that performs. Definitely something wrong with the mouse. It's resetting itself and then it flashes. But it's not doing its normal low battery flash. So either it's getting interference or it's just on its last legs. I'm gonna buy another one of these generic mice as a temporary holdover until I get paid, and then I'll buy the bigger, more expensive mouse that I have in my wish list. And I'll probably go to the store and pick up some extra batteries while I'm at it. Ooh, on sale, 10% off. Don't mind if I do. Okay, new mouse on order. does it do that? Okay. That's that, and then let's see if I can't get these traces across. There's one. Next one. And then that's that. Still thinking I might need multiple layers, because I still have these connections to do. Let's at least try to get the SPI bus in place. Ethernet chip select. So this is reset. And then I need, oh yeah, RX and TX have to come over here. Probably play a game of hopscotch to get it over, but I'd love to keep it 2 layers if I can, but I don't think I can. Is this one, which is the chip select. Let's see if I can do RXTX. What do you know? I didn't have to play a big game of hopscotch to make that work. I was expecting to have to go up and down to make that work. What do you know? I have a feeling that if I play around with these wires, I might actually be able to make it work too. And make it work on 2 layers. The other part I can do is I can finish off the SPI bus. Connects those 2 spots. And then here. And this one here. And then what I need is the actual SPI bus. I'm gonna remove this for now. like it'd be better to not have this big gap here. And we can do instead that. What in the world? Make some space for this ground over here. And then I just have to fix these lines over here. So the only thing that leaves are all the inputs and outputs on the MCPs, which correspond to all the pogo connections. But I think that is a good